Okay, today's lesson we're going to learn about factoring special products. So if you recall in our previous lessons, we talked about perfect squares and the difference of two squares. So if we take a look, if you remember, when we had x plus 2 times x minus 1, to quickly solve this, or to multiply it, we squared, squared, and subtract. So that gave us x squared minus 4. So if we see a polynomial like this, we'll know we can quickly factor it to here. So if we take a look, we need to make sure these are both perfect squares, which they are. So that leaves me with x plus 8 and x minus 8, because the square root of 64 is 8. Now if I look at b, a little bit trickier here because I have a leading coefficient. However, my leading coefficient is a perfect square. So the square root of 5b squared would be 5b. The square root of 36 is 6. And of course, to get a negative, that means one must be positive and one must be negative. So we end up with 5b plus 6 and 5b minus 6. Now, how could I do that? How could I use that information to help me solve a problem like this? Well, what I can do, since these are both squared, the square root of those would be 68 and 62. So I could do 68 plus 62 times 68 minus 62, which would give me 130 times 6, which would give me a final answer of 780. Go ahead and hit pause and try the next 6 on your own. All right, for number 1, we ended up with x plus 6, x minus 6. For 2, 10 plus m, 10 minus m. Could I have the positive and negatives or the plus and minuses switched? Absolutely. 3n minus 4, 3n plus 4, 4h plus 7, 4h minus 7. Final answer here of 140. Final answer here of 273. All right, so if you remember, we now have a perfect square here, which would mean we have something that looks similar to this. And of course, we could always FOIL, but if you recalled, when we learned about this in the past, we said to square, and then multiply and double. So that gives us x squared, multiply together, x times 2 is 2x, double that, plus 4x, square this, we end up with 4. So square, square, multiply, and double. Now, if I had x minus 2 squared, square this, x squared, square that, it's 4, multiply and double, watch your negative here, so that's a negative 2x, double that for a negative 4x. So be careful, watch your negative signs here. So if I take a look, I am looking for some perfect squares, perfect square, and is this the sum of those perfect squares? So let's try this. So the square root of 169 is 13. That gives me x plus 13. Add those together, I get 26. So my final answer here is x plus 13. Oops, that should be squared. All right, now this one's a little bit different because we have that cube here, or that 9 here. So if I were to factor this, 3x minus 4, 3x minus 4. So let's double check. So there gives me my positive 16. There gives me my 9x squared. And then when I do the middle terms here, that gives me negative 12x minus 12x, which gives me negative 24x. So my final answer here is 3x minus 4 squared. Now, with fractions, let's be honest, we don't want to deal with fractions. So let's not. So I want to get rid of this fraction. Well, how do I do that? If I multiply all of these by 4, which would be my common denominator here, that will eliminate my denominator. So here, 4x squared plus 12x, and then 9/4 times 4 plus 9. Now I'm going to solve this one because that equals 0 here. So I've got a perfect square, and we'll double check our middle term. So that's 2x plus 3 times 2x plus 3. So let's see, this gives me 6x, 6x. So all set, because 6x plus 6x is 12. So I know this is correct, which leaves me with 2x plus 3 squared equals 0. And I really only need to set one of these equal to 0 because I'm going to get the same answer both times. So 2x plus 3 equals 0. Subtract 3 from both sides. 2x equals negative 3. Divide by 2. X equals negative 3/2. All right, go ahead and hit pause and try the next 6 on your own. All right, so number 7, you'd end up with m minus 1 squared, d minus 5 squared. Now here, if you notice, I could actually factor out a 9 first. So I'm going to go ahead and do that, leaving me with z plus 2 squared. If I factor out a 9, I end up with z squared plus 4z plus 4. Remember, always look to see if you can factor out something first. Saves yourself a little bit of time. Okay, so when we factor, we end up with a plus 3 squared equals 0. So a is going to give us a negative 3. Now here, if you notice, I have a denominator of 3 and a denominator of 36. So what I'm going to want to do here is go ahead and multiply that by 36 to get rid of my fraction. So I now have 36w squared minus 84w plus 49 equals 0. I've got perfect squares here. So I end up with 6 minus 7, or 6w minus 7 times 6w minus 7 equals 0. So 6w minus 7 equals 0. So w equals 7/6. Okay, and for our last one here, we've got n squared minus 81 equals 0. Perfect square, difference of a perfect square. So that means we have n plus 9, n minus 9 equals 0. Then in this case, we're going to set both of those equal to 0. However, they are opposites, so I really only need to solve one. So I know my answers are going to be 9 and negative 9. All right, and let's take a look at a real life example here. So a bird picks up a golf ball and drops it while flying. The function represents the height in y that the ball was dropped, t seconds. The ball hits the top of a 17-foot tall oak tree. After how many seconds does the ball hit the tree? Well, that means I'm going to have 17 equals 81 minus 16 t squared, set equal to 0. So we end up with 64 minus 16t squared, because I subtracted 17 from both sides. So when I factor that out, I get 8 plus 4t times 8 minus 4t, although I just said that backwards. Set those both equal to 0 and solve. So we end up with t equals 2 and negative 2. However, remember we cannot have negative time. So our final answer is 2 seconds. All right, hit pause and try 13. All right, number 13, we're going to set that equal to 13. So it's a 13-foot tall building, set equal to 0. Now I'm going to factor out a negative 1 to make it a little bit easier on me. So when we do that, we end up with negative 4t plus 6 times 4t minus 6. Set those both equal to 0. And because they are opposites, I know my answers will be opposite, so I really only need to solve for one of them. So my final answers here are 3.5 seconds. So my final answer is 1 5/10 seconds, because as stated before, we cannot go back in time.